Now in this lecture we will look at another problem which we solved using divide and conquer approach, and here we will solve the same problem using dynamic programming. So the problem name is house robber problem. Basically the problem statement says that you are a professional robber planning to rob houses along a street. So each house has a certain amount of money, and the only constraint stopping you from the robbing of each of them is that the adjacent houses have security system connected to them. So it will automatically contact the police if two adjacent houses were broken into on the same night. So given a list of non-negative integers representing the amount of money of each house, and determine the maximum amount of money you can rob tonight without alerting the police. So this is very interesting problem. So here let's understand it using this example over here. So let's imagine that we have houses like this. So in these houses we have certain amounts of money over here. So this number expresses the amount of money. Now we know from previous section that if we solve this problem, the answer will be like this. So we are robbing from second house, then fourth house, then the last house. Now here the maximum amount is 41. So if we sum up these amounts over here, we will get 41. So here you can see that we have not violated the constraint that we cannot steal from the adjacent houses. So this is how our problem looks like. So as you remember, we have solved this problem using divide and conquer algorithm. So to solve a problem using divide and conquer algorithm, you have to divide this problem into subproblems. So in our case, we had two options. So by calculating these two options, then we are taking the maximum amount from these two options over here. So here the first option is we are skipping the first house. The second option is we are stealing from the first house. So then after finding them, we are comparing the result and taking the maximum one, because in this problem we need to find out maximum amount. Now based on this logic, our algorithm will look like this. So here we have base conditions. So if the index of current house is bigger than length of houses, so we are returning 0. Otherwise we have two options over here. We are stealing from the first house, then we are continuing to the third house. That's why we put current house plus 2, because we cannot steal from the adjacent houses. Now in the second option, we are skipping the first house and we are continuing to the second house. That's why we put current house plus 1 over here. So this is the algorithm that we solved in case of divide and conquer algorithm. Now we know that if we want to convert this algorithm to the dynamic programming, first we need to find out the top-down approach, then we will use top-down approach to find out bottom-up approach. So in case of top-down approach, we have to implement 4 steps that we have explained in our previous lecture to convert this divide and conquer algorithm to top-down approach of dynamic programming. Now before implementing these 4 steps over here, we need to check that if this problem has overlapping subproblem property or not. Now to check it, we need to look at recursion tree of this algorithm. Now the recursion tree looks like this. So here you see that, so first if you are stealing from the first house, then we are continuing to the third house. So if you are skipping the first house, we are going to the second house. So this is how it continues. Now if we carefully observe this recursion tree over here, we can easily see that we are calculating these problems multiple times over here. So in this case, we calculate for house 3. So here also we are calculating for house 3, and we are calculating for house 2 over here. So these problems get solved multiple times. So this means that we have overlapping subproblem property over here, and we can implement dynamic programming. So as we mentioned, to implement dynamic programming from the divide and conquer algorithm to the top-down approach, so in this case, we have to implement 4 steps. So the first step is we have to create temporary dictionary to store the answers that we have already calculated. Now the first step is we are creating temporary dictionary and we are sending it as a parameter. Now the next step is we need to check that if the solution exists in this temporary dictionary or not. So if the current is not in temporary dictionary, then we will continue to these recursive calls. Otherwise, we are not continuing to the recursive call. We are just returning the value from this temporary dictionary. Now, as the third step, we need to insert the solution to this temporary dictionary over here. So here, we are inserting the solution to this temporary dictionary over here. And in the fourth step, we are returning this value from this temporary dictionary. So if the result exists in our temporary dictionary, we don't need to calculate it again. We just return it from the temporary dictionary. So these are the 4 steps that we are implementing to the divide and conquer algorithm to convert it to dynamic programming of top-down approach. Now with this, we have completed our top-down approach algorithm. Now let's see how this temporary dictionary gets filled in case of house robber problem. So if we carefully observe this temporary dictionary, then we can find solution for bottom-up approach. Now in this case, we have a table like this. So these are the houses. So we need to find the maximum amount from these houses. So we know that in case of top-down approach, we are calculating the top problem first, then we are continuing to the bottom problem. So our top problem is to calculate for the first house. So in this case, we are taking first house and plus the result from the house 2. And the second option is we are skipping the first house and finding the result from the second house. So in this case, we need to calculate this equation over here. Now, we know that we haven't calculated the results for second and third houses, so we need to calculate equation for this house over here. So in the second step, we are calculating second house. In the third step, we are calculating third house, fourth house, and fifth house, sixth house, and finally the last house. So these are the equations we are calculating. Now from here, you see that we cannot break our problem into sub-problem anymore because we have reached the smallest problem. Now here you see that to calculate house robber problem for sixth house, we need to get the result for the house 6, which is 4, and we need to calculate the result for house robber problem for 8 and house robber problem for 7. So we know that we don't have these houses over here, so this means that this result will be 0. So the value for this house robber problem of 6 will be 4, because in this case we have only this result over here. So the result will be 4. Now based on this, we can calculate result for house robber problem of 5. So in this case it's going to be 4, because here the value in house 5 is 2 and the value that comes from the house robber problem of 6 is 4. So the maximum value is 4. Now in the next case it's going to be, we are comparing 4 with 8, because the value in house 4 is 8 and the result from the house robber problem of 6 is 4. So if we sum up them, we are getting 12. So if we compare them, the 12 is the maximum value from here. Now it continues like this until we reach the final problem. Now the final answer is 41. So these values are calculated based on these equations over here. So I'm not going to explain them one by one. So if you look at them carefully, you will find out how they are calculated. Now here you see that first we have started from the main problem, which is the top problem. Then we continue to break the problem into sub-problems. Then when we reach the minimum problem, we have calculated minimum problem and come up to find out the final problem. But in case of bottom approach problem, we will do these steps in reverse order. Now here we will start from the bottom problem. Now the bottom problem should be n plus 2. So we have two bottom problems over here. So here we need to calculate it for n plus 2. In this case we have 7 houses. So we need to calculate house robber problem for 8 and 9 houses to calculate this equation over here. Now we know that we don't have these houses over here, so this means that the value from these houses will be 0. So based on this one, we can calculate house robber problem for 6th house. So it's going to be 4, because the value in it should be house 6 over here, so I mistakenly put house 5. So the value from the house 6 is 4, so the value will be 4. Now based on these equations, it continues like this until we reach the final problem. So the final problem is 41. Now here you can easily see that we have started from the bottom problem and we have continued to the final problem. So this is the reverse order of top-down approach. Now based on this logic, the solution of bottom-up approach for house robber problem will look like this. So this is how our algorithm will look like. So here, first we are creating temporary array and we are setting all values to 0. Because in this case we have not calculated the values. Now here you need to take into account that we are creating temporary array with a number of houses plus 2, because according to our equation we need to take the value of house, current house, and plus the house that comes from the next house. Then we need to compare it with the value that comes from the next house. So this is how our equation will look like. That's why we need to take houses plus 2. So as we mentioned, we will start from the bottom sub-problem. So that's why our loop will start in reverse order. So in this case, we will start from the last house and come to the first house. Because to calculate last house, so we know the base condition. So that's why we can calculate it easily. Then from there, we can calculate the final problems. Then at the end, we will return the value for the first house over here. So this is how our algorithm looks like in case of house robber problem for bottom-up approach. Now in the next lecture, let's use this logic to create two methods for calculating house robber problem in case of dynamic programming for both approaches, bottom-up approach and top-down approach. So see you in the next lecture.